Okay, welcome back. Moving right along, lesson 3, adding and subtracting whole numbers. So in a pre-algebra course, I assume that you're comfortable with adding and subtracting whole numbers, but what you may not be comfortable with, or you may be rusty on, is the algebraic properties of addition and subtraction. So, meaning what? Do you have memorized the commutative, the associative, and the additive identity properties? And most people will say no, but it's actually something simple that you've known since you were little, but we're putting a name to it. That's what's different. So, and also when you're reading a word problem, can you look for key words for addition? Do you know what key words trigger you that you need addition in that word problem to solve that word problem? So we start off by discussing 3 important properties of addition: the additive identity, the commutative property, and the associative property of addition. These properties you have probably known since you were little, but like I said, we're going to put a name to them and devote them to heart. Typo there. That should have said heart. This helps us develop our number sense. It starts to tell you what's legal, like can I subtract 2 numbers in any order and get the same answer? Is 7 minus 3 the same thing as 3 minus 7? No, it's not. So we're going to find out what's legal here pretty soon. All right, let's start off with the additive identity property. You've probably known since you were pretty little that 5 plus 0 is 5 and 0 plus 5 is 5. That means that if you add 0 to any number, you get back that number. So the sum of 0 in any number is that number. That's the additive identity property, you see? So nothing difficult, it's just that you have to memorize what it's called. So if I tell you to recite or give me an example of the additive identity property, that's what we're looking for, okay? Let's try again. Commutative property of addition means that changing the order of 2 addends, that means 2 numbers that you're trying to add together, does not change their sum. Meaning what? Well, hey, 7 plus 8 is 15, but if you change the order, 8 plus 7, you still get 15. So, a more formal way of saying that is A plus B equals C. B plus A will also equal C. So if A plus B equals C, then B plus A will also equal C. You know what I mean? Order doesn't matter with addition, but it does matter with subtraction. So that property does not hold with subtraction. Let's try again. The associative property of addition. Changing the grouping of addends does not change their sum. And I'll zoom in on that. It might be small on your video there. It says 3 plus 4 plus 2 with these guys in parentheses. Does that equal the same thing? And then look down here. Does that equal, I'll put a question mark. Does that equal the same thing as 3 plus 4 plus 2? And notice the switch in parentheses. Here it's around the 4 and the 2. Here it's around the 3 and the 4. So let's try it. Okay? Let's see that done in real time. Well, 4 plus 2 is 6. And 3 plus 6 would lead me to 9. Oops, sorry, the pen was being fussy there. 3 plus 6 would lead me to 9. Here, 3 plus 4 would lead me to 7. But hey, 7 plus 2 would also lead me to 9. 9 equals 9. Yes. So changing the grouping of addends does not change their sum. But remember, this will not work. So this one and this one do not hold true for subtraction. Do not hold for the operation of subtraction. Okay? And that's just, I kind of wrote out that reminder there. Remember that commutativity and associativity does not hold for subtraction. The difference of any number and that same number is 0. So subtraction really doesn't have a lot of properties other than some properties of 0. There's no fancy name for these other than properties of 0. It's really any number minus itself gets you to 0, and any number minus 0 gets you back to itself. Okay? And again, just a recall that the commutativity and associativity does not hold for subtraction. Now I am going to insert a little example here in our notes. Can you give me an example of the associative property being used? So this is, this is creative. So let's try something. 7 plus 8, so you'd have to know, that would be like a good test question. So 7 plus 8 plus 6 with these two in parentheses. And you're illustrating that that's the same thing as 7 plus 8 plus 6 with these two in parentheses. That's what the associative property says, that you've got, see, 7, 8, 6, 7, 8, 6. You've got the same numbers, but you've, note to self, changed the grouping. And that changing the grouping does not affect the outcome, right? So here, 8 plus 6 is 14, but 7 plus 14 would lead you to 21, right? Try here. 7 plus 8 would lead you to 15, but hey, 15 plus 6 then will still lead you to 21. So we changed the grouping and the outcome was the same. So you could get creative, on an exam and give me lots of examples of the associative property that it holds true. Okay, another key reminder is reminders on special words for addition or keywords for addition. A lot of students tell me that they read a word problem and they're not sure whether they should add, subtract, multiply, or divide. So there's keywords that can help us, right? Be on the lookout. This is a snippet from the Martin Gay text. Be on the lookout for added to, plus, more than, total, increased by, sum. Perimeter is also a keyword for addition. That's kind of a tricky one. And then there's things that cue you for perimeter. I had a woman from Russia once. She came up during an exam and she said, "What are gutters?" And so, gutters go around the perimeter of the house. It was a word problem that was trying to find out how many feet of gutters she would need. Well, you had to know you had to go around the perimeter of the rectangle or whatever figure it was. So the perimeter of a polygon, whether it's a rectangle, a trapezoid, or a triangle, is the distance around the polygon. So you would be adding the sides. So be on the lookout even for those kinds of problems. Okay. So I just cooked up a classic example of how something might be worded. This example here, how many feet of fencing are needed to enclose this yard here, right? This rectangular yard. But keyword enclose and keyword fencing. So we're not looking for the interior space. We're looking to go out around, right? Fencing, keyword for perimeter, which is a keyword for add, right? Add the sides. So 80 plus 80 plus 20 plus 20. Okay. Survey says. So 80 plus 20, you can even write that out, is 100, and then another 100, so 200. So you would need 200 feet of fencing. So the answer there would be 200 feet. Okay? So just be on the lookout for words that might trigger you for adding, such as how much fencing, how much framing, more than, increased by, those types of things. Likewise, there's got to be keywords for subtraction. So a word problem that involves subtraction, look out for the word difference, less, take away, and see how the translations are over here. 12 less 8, translates to 12 minus 8. 14 take away 9 translates to 14 minus 9. Big star on this one. This is the one that gets people right here. Subtracted from. When you say 5 subtracted from 9, look at how that translates. 9 minus 5. You see that? So just be careful with the translation. A big sort of warning here, if you will, is that when solving word problems that suggest subtraction, be careful, because order does not matter with addition, but it does matter with subtraction. So, all right, here's a good example for us that simultaneously makes us, I'm going to make it larger here so we can see it. Makes us read a bar chart, which is a good skill as well. We have number of endangered species, and we have various countries here. And the question says, what is the difference in the number of endangered species for Indonesia and Brazil? Keyword difference. Well, how many endangered species in Indonesia? 146. How about Brazil? 73. Aha, so 146 minus 73. Now everybody was trained to subtract differently depending on what country you're from, but here we borrow. So 6 minus 3 is 3. 4 subtract 7, you can't, so you're going to borrow from this guy. And that's going to become a 14. And 14 minus 7, you're borrowing 10. So that becomes 14 minus 7 is 7. And the nice thing about subtraction is you can check your answer by taking 73 plus 73 and seeing that you get back to 146. Okay. Fancy words that you may have forgotten when you're subtracting. This guy is the minuend, and this one is the subtrahend. Those are words that we don't use much anymore, but if you take the result, in the subtrahend and add them together, you should get back to the minuend. Okay, hope that helps. And voila, you got through your notes for adding and subtracting whole numbers. Good luck out there.